Okay, so it's almost time. Thank you everyone for coming. We're going to start the technology session. Today we are very fortunate to get our chief architect for our carrier business unit to talk about technology. And Chang Yue, he has been instrumental in bringing our revenue to pass the 100 billion mark last year. So we're fortunate. Let's welcome Chang Yue to talk.
Good afternoon, everyone. So I'm very glad to have opportunity to make a presentation about our ideas and some practice in network architecture evolution. Also, because I'm responsible for the product and the solution architecture design. So we feel in the recent years, the network world faced a great challenge. So I hope my sharing will be benefit and helpful for IETF to let us to face the challenge together. So okay, let's begin. Okay, thank you. So during the past several decades, IETF and engineering made a great contribution for the networking in the world. So currently, the IP network has already almost covered all of the world and become the very important infrastructure for the information world. So more and more application and services rely on the network infrastructure, such as cloud, internet, and in the future, maybe the IoT. So on the contrary, so these applications rely on the network. On the contrary, so the network faced great challenges for the new requirements. So, so for the IP network, we think there are major three segment market. The first, the cloud network. The second is telco network, and the third is enterprise network. So today, my topic is mainly focusing on the telco network. So currently, the telco network faced great challenges in the industry. So in the summaries, from the external, we can see in the future more and more application and network will rely on it. So in the future there are maybe more than 75 billion devices will connect with the network. But at the same time, for internet, currently the network mode, the delivery mode, the operation mode, there is a great gap for the requirement. For example, so the OPEX increased greatly. So almost occupy more than 70 to 80% of the TCO of the carrier. So this means, but at the same time, the revenue increase is very slow. So this means it is difficult for carrier to invest continuously for the network. This is the first. So the reason for the OPEX increase, we think maybe the low maintenance efficiency, because we think the major reason is the telecom network maintenance depends on the human experience very heavily. So this is the great challenge. So how to solve these challenges? I think we need to think about the system architecture innovation. So we think autonomous network will be the future of the network architecture. So before to think about the autonomous network, we make a deep study about the current network of OTT and telco network. So the right side, okay, the left side is a typical cloud network architect. So the right side is the typical network architecture of the telco. So for the cloud network, we can found. So there are the following character. The first is decoupling of the transport and the services. So transport is realized by the hardware and with the lifespan architect. It is easy to scale out. So the services is realized by the software. It is easy to deploy with the change of the workload and application. So at the same time, so there is a very clear boundary of the cloud services at the network operation layer. So and all of this process are realized by the software to realize the automation. But for the telco network, so currently the transport and network services in general converge in dedicated hardware. So it is difficult to scale up for network transport and network services independently. As we know, when we developed the product, we know the network services and the network transport rely on different process, different hardware features. So within one box, it is difficult to scale up independently. So the second difference is, so currently for telco network, their services and management system are silo system. So so for example, there are a lot of network services and management system for access network, for metro network, for example, for the call network. So at the same time, the boundary of the network services and network operation is not very clear. So in some area, maybe they realize the service system will talk with the device directly. For example, maybe some use case, some OS system talk with access node directly. So, but for other scenario, maybe the services platform will talk with network, with the operation team, with the people. So here, so this means a lot of work should be done by people. This is the great difference between the OTT network and the telco network. So to discuss about the autonomous network architecture, maybe it is necessary to think about the value and the goal, the over picture of the value of the goal of the network. So we think the final target is increase the revenue and decrease the TCO. But there are three major value proposition. So that is a better customer experience, higher operation efficiency, and open programmability. For operation vision, I think zero touch operation is the target. So maybe in the future we need so for the target we need to make the knock easy and simple, and we need to solve the challenge of continuously service provisioning for the network. Currently, it is difficult to continuously deliver the service on network. In general, for telco carrier, they have a change window for the network modification. And another challenge is how to mitigate migration from the legacy network. So in general, if currently for the telco players, if they want to introduce a new device or new vendor, it will invest great to adopt the new device. And so this is so to solve this problem, we need to think about the architecture and some technology. Later, I will maybe introduce some part of this. Okay. So this is a general idea of the autonomous network reference architecture. So the right side, so for the network itself, we think we think maybe we need to decoupling the transport and network services function completely. So because so for network transport, network transport is focused on the bandwidth increase, the bandwidth utilization, and the SLA guaranteed. But for so this means transport mainly focused on the physical infrastructure. But for network services, in fact, it focused on the user and the subscriber itself. It's an application. So this means for user and for tenant, the most important feature is could you deploy the services agility, flexible, and have a good and can guarantee the service experience of the customer. We can find the logic is different for the transport and network services. So this is why we think in the future the network, the decoupling of transport and the services are very important. And maybe in the future, based on the hardware and silicon technology progress, we think maybe for the transport network, it will be more rely on the dedicated hardware and the chip side. But for the network services, it's more rely on the software based on the general purpose computing capability. So this is for the network hardware, network itself. For the network services and the management system, we think how to say, to change the current vertical silo system to the horizontal system. So it's very important. So this means we need to establish a common platform for network operation and a common network service platform for services. So in one hand we can so based on this platform, it is easy to, maybe it is benefit to deploy the network transport and the network services end to end, and all of this system should be executed by software. So this is the left side. So how to realize this network management and the network services platform? We call it autonomous control system. The right side is the general idea of this architecture. I think we think this ACS system should be consist of the four major engines: the intent engine, automation engine, elastic engine, and the intelligent engine. And all of the engine should be work in a closed loop model. This means it can realize the autonomous in each layer. Okay. So because there are a lot of challenges and technology issues need to solve for this architecture. So for today's presentation, I will mainly focus on the three topics. The first one is the decoupling of the transport and the services. The second is about the how to realize the automation, and the third part and elastic, and the third is about the model definition. So for decoupling of the network services and the transportation, I think this is not a new ideas in this in the industry, but the challenge is we found how to say, some protocol didn't have a very clearly boundary between the transport and services, and the other protocol maybe for example the MPLS, and other protocol maybe it is how to say, it realized a very decoupling between the network transport and the network services. But in general, they have a, how to say, it cannot realize the agnostic. So, for example, the VXLAN. So this is the we think maybe we currently for the net protocol evolution, we think maybe the following three principles are very important. The first is the network service and transportation technology are agnostic maturely and can be replaced independently. Means maybe replaced all evolution independently. The second is various transportation with different technology can be chosen for the specific service. Later, I will share a use case of SD-WAN. It's a typical scenario for the second principle. And the third is multiple kind of services can be supported by the specific transportation technology. I think we think maybe this principle are very important for the protocol evolution. For the transport layer, we think maybe in the future the target of this layer how to guarantee the capacity growth and the resource utilization with reasonable cost. The second is how to visibility and guarantee SLA of the services. The third is how to achieve always on delay. So this is to realize this target. We need to think about we think something need to think about. The first, we need to simplify the protocol system and to realize to support the end-to-end. Maybe next slide. Okay. So this slide shows some ideas about the protocol evolution. The first is seamless. So because currently the services or the transportation function rely on the hop by hop configuration, and this is why it is difficult for telco to provide the services to the customer very quickly. And the second is currently the protocol is very complex, so it is difficult to maintenance and also difficult to realize the automation, because if we realize the automation of the network, if we have to deal with all kinds of protocol and all kinds of a lot of scenario, it is very difficult. So another idea, I think we think maybe this technology can be used for all kinds of scenario, so from the access to mature and to call. Why we think about this? Because we think currently the telecom network is how to say is a hierarchy and layer aggregation network from access, mature, and to call and connect to the internet. But in the future, we think with the cloud, with the cloud become more and more popular, and recently edge computing is also become more popular. We think in the future the underlay transport network should be a basic infrastructure to connect the multi-cloud. This means the traffic pattern will be changed, and the network, how to say, just like a fabric, can support all kinds of traffic among the cloud. So this is why we think maybe in the future the idea is that the underlay transport network should be a flat network, can provide very big bandwidth and scale out very easily. This is the basic idea to think about the transport network. And for the overlay network, I will share two use cases we are use cases to understand the requirement of this network. The first one is to establish the cloud-based overlay network for the customer. So we during the past 2 years, we developed this network based on our public cloud, with cooperated with France Telecom, Dutch Telecom, and China Telecom. So the idea is we hope to deploy. The target is for the customer, one point access for the globe network. This means if the customer access network, we can deploy the virtualized network based on the cloud infrastructure, and to realize the globe connection for the customer very quickly. So this is the second. So service provisioning in minutes and the routing convergence in second. Currently, if you just rely on the telco cloud, it is difficult to realize this target. So this is what we are. This is the target we developed this network. So besides the traditional VNF, such as DVR and the VPC gateway, we added two new VNF. One is a VPN gateway. Another is X gateway. VPN gateway is used to access point to all kinds of to the customer, while the different technology such as the LISLAN, MPLS VPN, or IPsec VPN. So X gateway is used to interconnect with the different data center. So this is the basic solution for the overlay virtualized network. So when we developed this gateway, here is a more detailed information about how to realize the services requirement. So for the customer access the data center and access their own VPC in a local position or in a remote position. And based on this network, it is also can support the customer connect the network via the cloud. So, but when we developed this component, such as the V gateway and the X gateway, we found a lot of challenges never faced before. For example, the first is the capacity. So because this X gateway and the V gateway will connect a lot of customers, so here the capacity is not as a challenge. Is not the bandwidth. It is a control plan. In general, the specification for the X gateway should be support more than 50K BGP session and peers at the same time. So in general, for the traditional network product such as a call router, in general, 1,000 peer is enough, and it is a challenge. But here we need to support at least 50K. So this means, and at the same time, we need to add feature easily, because we will support the IPsec, we will support the SFVPN, we will support the MPLS, and in future we need to add some more and more feature. This is the second. So because of the capacity and the performance requirement, or the traditional network product reliability cannot satisfy. The traditional network just supports the 1+1 control plan and as a backup. But we think to support this scenario, we think M2N model should be supported. So there are a lot of technology should be solved. Here is a typical example is, as we know, currently the BGP connection rely on the TCP. But when we realize the network function on a server, we know the reliability of server is not very high. In general, server will be down. So currently, if the BGP rely on the TCP, it is a great challenge to realize the high availability. For example, end-to-end model for the control plan. So this means we need to run several control plans at the same time, and maybe select the best result of the different control plan. And in the future, we hope we can upgrade the control plan. How to say individually, and maybe within the different version of the software. So all of this feature rely on the BGP connection, the robust of BGP connection. Maybe currently we use some software technology, very complex software technology to solve this issue. But we think maybe if we think about the evolution of the BGP, maybe it's better. So here is just an example for the VNF. Okay, next slide. So another use case, SD-WAN. So currently SD-WAN is a very hot topic in the industry. So I think in fact it is an overlay network based on the internet and maybe based on at the same time based on the telco LISLA network for the enterprise. So when we develop this solution and cooperate with telco customer, we found the following requirement. So the first scale, because in general there are thousands of sites for the enterprise. So the scale is very important. So the second is how to say advanced routing technology is necessary. In general, for the SD-WAN, because in general there are several channels to transport the service. For example, one is MPLS, another is internet. So how to select the different channel? So not based on the service experience, based on the policy. So this is a very key feature for the SD-WAN. And another important thing is security, because we deployed the network on the internet. The security consideration and the deployment are very important. The third challenge is about the policy, network policy, because when we deploy the VNF so dynamically, so how to guarantee the policy consistent? It is another challenge. All of these things, in fact, different vendor have a different innovative ideas to solve these challenges. But currently, almost all of this solution are based on the proprietary solution to, for example, expand by the BGP. So we hope maybe IETF can do more contribution in this area, because so this means in the future it can help to realize interworking with the different vendors SD-WAN solution. So this is the second use case about the overlay network. Okay, so next topic about the autonomous network is to realize the automation. So I think to realize automation, the basis and the fundamental issues is model. So we think maybe in the future, at least there are three levels of model: the network device, network element model, so the network model, and network service model. So because all the software automation rely on the model, so we think model definition is very, very important to realize the automation. So this is okay. So currently, IETF has already made a lot of has already established a work group and draft for the model definition. At the same time, in the industry, there are a lot of organization and vendors and the customer to define their own young model. For example, OpenConfig. For example, as a Cisco and Huawei will has already released their private model. So I think we think IETF is very important to lead all of this organization and the players to define the relative standard model. It is very important for the industry. So this is okay. This is about a young model. So the last very important design is about the analytic and intelligent of the autonomous network. So we can here is a use case about to compare to show the challenges for the autonomous network. So in general, currently the root cause. So how to say? The network should have fault, can influence the services deployed on the network, but there are different words. So in general, for the network operation, the fault can be caused by the error configuration, the bug of hardware and software, the software. So, but for the services, they don't care about these issues. They care about the service experience. So the policy can be executed correctly. So there is no correlation between the network fault and the services experience and fault currently. This is a major challenge for the network operation and for the end customer. So we think why the reason for that, the first is the lack of data for the fault cause analysis. So the second is it is a lack of the mechanism to unveil the application or service experience. So and the majority failure are detected passively. This means maybe driven by the complaint of the end customer. So maybe customers say, "Oh, I cannot access the internet. Oh, my video quality is very bad." But currently, we can currently the network operation cannot find these issues proactively. This is the third is lack of the capability to correlate the issues between the network and the application. So all of this, how to solve these challenges, I think the basis telemetry is very important. We need to change the traditional network network status collector and mechanism to the future. So from the polling based and focused on the device status, expand to the telemetry based, focusing on real time status of the network, and expand from the static topology based, focused on device link, to the dynamic path based, focused on the application flows, and expand from the expand from the focus on the management to the not only management plan but also control plan and the forwarding plan. So, and at the same time, based on this data, we can correlate. We can establish correlation between the network status and the services status. It is benefit for the analysis and maybe next step for the intelligence of the network. So this chart shows an overview of the full stack for the network analysis and the intelligence. Based on this chart, maybe we can understand the issues we mentioned and more well. So from the bottom up, we think there are at least 3 layers for the network analysis and the intelligence in the future. The bottom line is a network device itself. So in here, so we think we need to expand, we need to strengthen the data collection capability, not only focused on the management, but also includes the control plan and the data plan. This means the challenges, this means we need to develop some new protocols and format and mechanism for this, for different data collection. For example, for data plan, the volume of data is very, very huge. Maybe we need to design some new mechanism to collect this data. So above the network is a collect layer. So based on collect layer, it can adopt to different interface to network. So I think the interface between the collector and the network are very important. So in here, if IETF can lead to define the relative standard protocol and encoding and the format for the data collector, it is very benefit for the industry. Above the collector, so we think maybe it is necessary to deploy two layers analysis. One is the online analysis near to the network itself, and then maybe another is the offline analysis system, mainly used for training and studying. So this is so it's for the online analysis platform. It will provide the data lake, can gather all kinds of data, can share the data for the network maintenance. So it is very important to solve the silo system maintenance issues. So this is the basic architecture. So next, I will share a use case about the network intelligent realization. What is basic model and what is the challenge? So this story is very interesting. It's not very related with protocol. It is about the physical network. So for a physical PON access network. So for FTTH, we know the telco vendor will provide a very huge and a large scale passive optical network to the customer, to the home gateway. So to maintain this network is very challenging. So because it's a passive network, how to find or locate the fault of the network and where is the fault occurred. It is very difficult because it is a passive network, and the situation, the environment is very complex. So the issues is not only the broken, but also maybe some the quality is decreased. For example, maybe for fiber, if we're overbending the fiber, maybe the quality will be decreased but not broken. Maybe the connector is losing. It's also this means the situation is very complex. So the second is why we need to locate the accurate position of the fault, because all of these issues should be solved by on-site engineering workload. So it is a great challenge. So based when we face this challenge, we use big data technology. So collect a lot of data from the ONT and ORT and extract the feature of this data and training the model for the training the fault pattern model. So currently we achieved a relatively good result. We reduced 40% of door-to-door services and increased the prediction of the fault 80%. But this is the good hand. The other hand is the left side, left part on the so to realize this realize analysis and prediction, we have to collect a huge of data. So here is a real example for the 10K access customer. For 1 week, we have to collect more than 6 terabyte data to analyze and analysis. It is a great cost for data transportation and data storage and data process. So the challenge is, so this means big data cannot solve everything, especially with the condition of the cost. So this means we think the domain knowledge introduced to improve the process, that data analysis efficiency is very, very important. So this is a use case to share this use case because the next slide. We think maybe we can. So for routing issues analysis and troubleshooting for routing issues, and maybe in the future to predict the routing issues, it is very, very important for the IP network. So this is a big problem from the birth of the IP technology. How to detect the failure of the routing, how to predict the failure of the routing. Maybe we can introduce a new technology, a data analyst technology for this area. But we think the domain knowledge is very, very important. To just rely on the generic big data technology, I don't think it can achieve a very good result. This is why I share the use case for the PON network. Okay, so last part about the security. Security is very important, especially in recent a lot of organizations, the country, and people think security is a big challenge for the network, for the social, and for the world. So, but I think we need to work together to solve these challenges. So we cannot let the security issues to prevent network interworking for the global network. So currently, so IETF has already developed a lot of security protocol, almost related to all aspects of the security, from the authentication to the encryption, for the integration, and a lot of technology. And in the future, the IP network should be a fundamental for all kinds of networks, such as 5G, such as IoT. So for different network, so maybe there are some different consideration about the security, how to adopt this technology to this solution. I suggest that maybe IETF can work more close with other SDO, with other organizations to solve the challenge. Okay. I talk a lot about the architect and the technology about the autonomous network. Frankly speaking, we think it is a long journey to achieve the autonomous network. We're just in the initial state. So based on our, we think so. Just like the automatic driver, we try to define the maturity level suggestion to evaluate the autonomous network from the level 0 to the level 5. There are some detailed information about it, but in the summarize, just like a human being, we think there are 3 capabilities are very important. The first is the hand to execute, to do something, and the second is the eye or ear to gather information, of the world, and the third is manned. So we use these ideas to think about the autonomous network to maybe as in the first phrase to realize the automation, and the next step maybe we can realize we can have a more strong capability to avail the environment, and based on the execution and the wireless of the network, we can establish the intelligent to realize the closed loop and to realize the autonomous network in the future. Okay, this is okay. The last part is a summarize about my presentation. I think maybe there are three. Well, I mentioned three major topics. The first is decoupling network transportation and services. So the second is decoupling the network operation and the service IT system. The third is the closed loop control to realize the autonomous and the AI in the network. So we think there are a lot of work we need to do to realize the autonomous network. Thanks everyone.
Thank you. And any questions? I know we are running a little short of time. Any questions from the audience? If no, and you're welcome to talk to Changyue afterwards in between sessions if you do have any questions. Okay.
Hello, Alexander Azimov. Thank you for this talk. It was really great. And my question is, I was not able to find the slides at the agenda page.
Oh, okay. Okay.
Okay, later I will upload the slide to the website.
Okay.
So.
Thank you.
Okay. Thank you very much. Okay. Thank you.
Okay, thank you.